So in this slide, I'm going to explain the asynchronous way of executing a Python program. Asynchronous mode is also called as concurrent model of execution or coroutines. So I'm going to explain this asynchronous method of execution with the help of same burger shop example. So in this burger shop example, almost all elements are same as the previous slide. Previously, we were discussing the sequential way of execution. So in the asynchronous way of execution, also almost all elements are same. You can see they have kitchen, they have a reception staff, and they have a queue of customers. um, they are here to buy the burgers, and additionally you can see a waiting bench is here. So it is very simple here. All other elements are executing same as before, but the only difference is that here the reception boy is more smarter. The reception boy is more smart. So he's very smart, and he is effectively and he is efficiently utilizing his time. So this reception boy means the Python virtual machine. So Python virtual machine is more efficient here. So they have a new concept here called event loop that we will see in the coming slides. So using this concept, the PVM handling the task more efficiently. In our burger shop example, our reception boy is more smart, so he is handling the queue more efficiently. How he is doing that? Because he is calling the customers one by one. We know there is no difference in that. He is calling the customers one by one and taking the order. The only difference is that when if the waiting time of the order is big, then he will ask the customer to wait in this bench, and he will call the next customer, and again he will take the order. If waiting time is small, then he will serve it quickly. He can serve it quickly. Then he will call the next customer. If his waiting time to prepare the food is big, then he will again ask the customer to wait, and he is calling the next customer. And frequently, again and again, he is checking, is the order for this waiting people is ready or not. If it is ready, then he is serving that order, and they are leaving. So as you can see, the queue will not be waiting. If they have a waiting time, he will ask that particular customer to wait in the waiting bench, and he will call the next customer. So it is an efficient way of handling the queue, and queue will not be stuck. It will not be waiting. The queue will be moving always, and this uh, reception boy is actually utilizing his time more efficiently. He's more active. So um, as you can imagine, PVM, Python virtual machine, is handling the task more efficiently than the sequential way of operation. But as you guess, it is a little bit more complex, because it should be written very carefully, because they have chance for the confusions. Uh, as we discussed before, one person's bill may be given to the other customer, and one person's order he may serve to one another person. Those type of confusions, chance for the confusions are bigger than the sequential method of execution, and the chance to get error is also big and a little bit more complicated for the programmers. So the waiting and who have to wait and who have to served instantly is decided based on the programmer. Programmer have to decide it, and he have to write his task or his program in such a way. Based on that only the PVM handle the instructions, and the PVM decide which one have to be wait and which one have to be served instantly. So it is up to the programmer. So we will see it in next slide. So in next slide I will just explain a little bit more how this is happening to make it more clear, and I will connect it with the uh, real Python environment. Okay, so let's move into the next slide. So in this slide I'm going to explain the asynchronous way of execution. So I marked here this I previously explained in sequential way of execution slide. So kitchen means CPU core, and reception or counter means PVM process, and the customers are the task or instructions. So PVM or the counter or reception boy fetch each instructions one by one. PVM fetch each instructions one by one. So in our burger shop example, the reception boy call each customers one by one. So he's calling the first customer. So this is the first customer. He's reaching the counter. He is giving his order. Then uh, the reception boy understand his waiting time is big. So the reception boy send the order to the kitchen for processing and ask him to wait. So he is waiting here. The customer is waiting in this waiting lobby. And after that, so his food is cooking here. His food, the cook is cooking his food here. So at that time, the reception boy call next customer. So uh, next customer reaching the counter, and he is giving his order. Maybe his order may be waiting time may be less, so he instantly serve that order, and he can leave. Okay, so after that he's calling next customer. So next customer is reaching, um, and his waiting time is also big. He's understanding the PVM or the reception boy is understanding the new customer's waiting time is also high. So he is also asked to be wait in the waiting lobby. So again and again this this counter boy checking with the kitchen, um, is it ready, is the order for this customer is ready, this customer is ready and all. So if it is ready, if the order for the first customer is ready, he is serving that order, and he is also leaving. So only one person is there, and after that he is calling the next customer. So you can see the queue is moving, and there is no waiting period here for the people in the for the customers in the queue. The queue will be always moving, and if it is waiting time is high, then the um, reception boy asking them to wait in the waiting area, and after that he is checking, is it ready, is the burger ready for all the people who are waiting in the lobby. If anything is ready, is serving that and calling next customer and checking again for the other customer, is their uh, burger is ready or not. So this is the way, this is a more efficient way of processing the um, counter or the reception. So, um, as I explained in Python terms, you can see they have CPU core, they have PVM process which is running on top of operating system, and they have tasks or instruction to be executed. The PVM fetch each instructions one by one, and if any instruction and waiting time is high, then it will be in a waiting loop. It will be in a waiting area, and the PVM fetch the next task to be executed or next instruction to be executed. And if it can be instantly executed, then it will be sent to the processor or CPU core through the operating system. Those things are handled by operating system, but PVM uh, call those operating system level functions, right? Those DLL or those system level functions. PVM call those system level functions, and operating system manages rest of the operations. Means converting into assembly language code and sending um, those codes into the CPU. Those type of operations are handled by operating system. So here you can see PVM. This is a PVM Python machine, Python virtual machine level type of handling of multiple functions or multiple tasks at same time. And if something is waiting, some of the task waiting time is high, then those tasks will be pushed into a task queue, and using a loop, those tasks will be verified. Is the uh, is it ready? Means is the return value is complete? Is it completed or not? If it is completed, um, it will be marked. It will be popped out from the task queue, and the loop will continue checking rest of the waiting task status, and also it will process next instructions. So this is how we will see these concepts more clearly in next slides. One more thing I have to point out here. So as you notice, they have three cores in the CPU, and only one is active. The other two cores are not active. So this is to indicate, this is to show the uh, nature of Python program. So normally all Python programs are running using a single process and single thread by default. If you want to run um, a same program in different process, you have to specifically write special type of codes for that. If you want to create new threads, you have to write code inside your Python code. You have to specify you need multiple threads, but normally Python execute using single process and single thread. In a single process and a single thread application, Python can only use one core at a time. In normal C Python type of implementation, even though you used multiple threads, it can only use one core at a time. So I am doing a separate video related to this topic in detail when I am explaining the threads, but currently it is out of scope. So just for your information, I am telling normal Python programs are running using single thread and single process and single thread. Um, and this single process and single thread can only use one process at a time, and which one CPU core at a time. So which CPU core have to be used will be decided by operating system, but um, only one CPU core can be used at a time, by Python program, by a single Python program when it is executed. So um, they have some more limitations in Python, but this is the way of Python program execution. So this is a limitation because even though, as you can see, they have multiple cores are available nowadays. In all processors are having multiple cores, but Python process can only use one core at a time. Even though you are using multi-threaded application, it can only use one thread at a time. So in this asynchronous way of execution, you in asynchronous way of execution, or in the concurrent way of execution, or in coroutine, we already see that it is running using single process and single thread. There is no other counters are available. Only one boy is here. Only one reception is here, and all instructions are handled in single counter or single reception. Only one boy is handling that. So you can consider this as a thread, PVM thread, this boy as a PVM thread. So in the normal asynchronous mode of execution, only one process and one thread is there, even though multiple functions are handled using this single thread by putting the waiting task into a waiting bench. So it is something like pushing the waiting task into a queue, task queue, and control will be coming back to fetch next instruction and executing it. So again and again, um, in this loop itself, in this single main loop itself, it will check the status of the waiting um, process. So if waiting is over, then it can move to the next operations of uh, that task. And again, if some waiting is coming, then the control will be switched into the next task or next instruction to be executed. So we will see it is a little bit more complicated. So we will see those type of concepts in coming slides. So this way, the execution or burger shop operation is more efficient in this asynchronous model. One more point I have to mention here is uh, about this area. So as you can see, this represents the processor. This area represents the processor, and if it is a multi-core processor, there can have multiple cores. So I represent each cook or each kitchen as one core of CPU. So this is a 3-core CPU, and I am marking this as two of these cores as ideal. So this is because normally these asynchronous programs are running in single process and in single thread. So in Python, a single process and a single threaded application can utilize only one CPU core at a time. So even though it is asynchronous, multiple tasks are handled. Uh, it is not handled. This asynchronous is not handled in multiple threads or multiple processes. This asynchronous way of implementation is implemented using single process and single thread. So within that thread is called the event loop. So within that loop, the Python virtual machine check the uh, tasks that are waiting, and after checking it, um, that are called the task queue. So those task queues are status of task queues will be verified, and after that the main loop of the thread will be fetching next instruction, processing it. So all these operations, right, all these operations are happening in single loop, the main loop or the single thread of the single process. So that is why um, asynchronous program is unable to utilize the other two uh, cores of the processor. Even though the core is available, asynchronous program is unable to utilize that core. It is only using single process and a single thread, and a single process single thread application in Python can only utilize one core, CPU core at a time. And within the CPU, within the thread, single thread, that thread is called the main loop. Within that main loop, it is fetching the instruction, and after that, uh, it is passing that instruction to the CPU core through operating system. And if waiting time is high, then it is pushing into a task queue, checking the task queue status, and again fetching the next instruction. So all these things are executed as a loop like this, you can see. So it is a loop, it is actually a loop. We will see these concepts in detail in coming slides.